Have you ever wondered how much water an underground aquifer can truly give up, especially when its levels start to drop? It is a critical question for managing our hidden water resources. The relationship between the water table and specific yield is fundamental to understanding how aquifers function. In simple terms, specific yield quantifies the amount of water that will drain by gravity from a saturated aquifer when its water table declines. This means the specific yield directly expresses the volume of water available for extraction or natural discharge as the water table moves downward. The core reason behind this connection lies in the physical properties of the aquifer material itself. Specific yield, often denoted as SY, is defined as the volume of water released from a unit volume of aquifer material due to gravity drainage, divided by that total volume as the water table falls. It is distinct from porosity, which is the total void space. Not all the water in the pores drains out. Some is retained due to capillary forces and adheres to the grain surfaces. This retained water is called specific retention, SR. Therefore, the total porosity of an unconfined aquifer is the sum of its specific yield and specific retention. When the water table lowers, the formerly saturated zone above the new water table transitions into the unsaturated zone, and the specific yield represents the water that was freed from that volume. Understanding this relationship allows hydrogeologists to accurately predict how much water can be sustainably pumped from an unconfined aquifer. To determine this, engineers and scientists often conduct pump tests, carefully observing the rate of water level decline and the volume extracted. They also analyze core samples from drilling, measuring the pore spaces and how much water different materials like sand, gravel, or clay can releases. This practical application ensures we do not overextract groundwater, which could lead to severe consequences such as land subsidence or depletion of essential water supplies. This crucial metric, specific yield, can also be thought of as the drainable porosity of an aquifer, emphasizing the practical volume of water that is truly mobile. It is a dynamic property, meaning it can vary slightly even within the same aquifer depending on factors like grain size distribution, degree of sorting, and the presence of fine-grained layers or lenses. For instance, coarse sands and gravels tend to have a higher specific yield than fine silts or clays because their larger pore spaces allow water to drain more readily against capillary forces. Accurate estimation of specific yield is essential for robust groundwater modeling and effective water resource planning. Ultimately, recognizing the close link between the water table and specific yield is paramount for responsible groundwater management. It provides the essential data needed to understand an aquifer's storage capacity and its ability to yield water, guiding critical decisions that protect both current and future water availability for communities and ecosystems.
If you love learning about water, like, subscribe, and keep exploring with us.